Okay, so here I am in the AWS console. I'm going to go over to EC2 and we're going to go and launch an instance, and this is going to be our NAT instance. Now, the easiest way to get a NAT instance is to go over to the community AMIs, and in here just type in NAT. And you can choose any NAT here, but I always choose the top one. So this is an Amazon AMI. It's a VPC NAT. It's using HVM virtualization. This is the date in which it was provisioned, and basically this is the one that I'm going to use for this lecture. So go ahead and hit select. I'm going to put that on a T2 micro. I'm going to go ahead and hit next. Now I'm going to deploy this into my VPC, and I'm going to put it into my public subnet. So it's going to be 10.0.1.0. I'm going to hit that one, and then I'm going to leave everything else as default. I'm going to go ahead and hit next, and I'm just going to call it my NAT. Go ahead and hit next. Now notice that I have to put it behind a security group. I'm going to do it under an existing security group, so it's going to be my web DMZ. With NAT gateways, you don't need to select a security group at all. Amazon handle all that for you, but with NAT instances, they must be behind a security group. So I'm going to go ahead and hit review and launch, and then I'm just going to hit yes, next for this one. Make sure I boot from SSD storage. I'm going to go ahead and hit launch. Then I'm going to use my German key pair and launch my instance, and that is it. So now it's going to take a couple of minutes for my NAT instance to boot up. The next thing I'm going to need to do is I'm going to basically need to create a route out to the internet via my NAT gateway. But before I do that, I'm just going to pause the video here and wait for this NAT instance to boot up. Okay, so my NAT instance is now live. I'm going to go ahead and go over to Actions and go to Networking, and here you can see Change Source Destination Checked. And basically what this means is that any EC2 instance by default must either be the source or the destination of any traffic it either sends or receives. Now we don't want this to happen for our NAT. Basically we want to route traffic through our NAT instance out to the internet, and then any traffic coming back, we want to allow that traffic. So I'm basically going to go ahead and disable our source destination check, and there we go. That's all I need to do now. One last thing I do want to do though is I just want to go over to my security groups. For my web DMZ security group, we don't actually have the HTTPS enabled. We've only got HTTP, so I'm just going to go in and add that. Amazon always recommend that you allow HTTP and HTTPS for your NAT instances, or for the security groups that are behind your NAT instances. So I'm just going to go ahead and hit save. And the very last thing we need to do now is we need to create a route from our private subnets out through our NAT instance to the internet. So of course what we would do is we would go back over here, go up into VPC, and then we're going to go and have a look at our route tables. So we go into our route table, and in here we've got our public route. Now we don't need to make any changes to our public route because of course it has a route out to the internet gateway automatically. What we need to make a change to is our main route table, our default route table, and we need to tell it in here, we're going to add another route. We're going to say o.o.o.o/o, and the target, if we click in here, we'll now see our NAT instance, my NAT, and we can just click on that and go ahead and hit save. So now in theory, our private subnet, any EC2 instances launched into our private subnet should be able to access the internet. So let's go ahead over to our terminal and test this. Okay, so I'm in my terminal window, and you can see that I'm SSH'd into my private EC2 instance. So the way I did that was obviously I SSH'd into my public EC2 instance. I then SSH'd over into my private EC2 instance. So this is 10.0.2.156. So now if I just run a yum, let's actually do yum install, and we'll just do MySQL, and then we'll do -yes. There we go, it has internet access and it has gone out and installed MySQL. It's as simple as that. So what I'm going to do now is quickly delete the NAT instance, and we'll try and we'll uninstall MySQL and try and reinstall it. So here I am in the EC2 console, go over to my instances, grab my NAT, and we'll kill him off, poor little guy. Go ahead and terminate the instance, and there we go. So now, in theory, what's going to happen is my EC2 instance in my private subnet will no longer have a route out to the internet. So let's go back over to my terminal window. I'm just going to do yum remove and then MySQL -yes. So we'll uninstall MySQL. And now what we're going to try and do is reinstall it. So yum install MySQL -yes. And you can see it's trying to download the packages, but it can't. And that's because we just killed off the NAT instance. So I'm just going to cancel this. So now I'm back in the console. I'm going to go back over to our VPC, and now we're going to go ahead and create a NAT gateway. So we go into NAT gateways, and in here you can see an old NAT gateway that I created. I'm going to create a new NAT gateway. We have to specify what subnet it's going to be deployed into. So we always deploy our NAT gateways into our public subnets. So I'm going to select 10.0.1.0/24, and then it's going to ask us for an elastic IP. I don't have one right now, so I'm just going to hit create, and it's going to allocate an elastic IP to our NAT gateway automatically. I'm going to go ahead and hit create NAT gateway. There we go. Straight away it says, in order to use your NAT gateway, ensure that you edit your route tables to include a route with the target of NAT, and then etc. So what we need to do is just go into our route table. We're going to go over to our main default route table, which is this one. So that's our main route table for our VPC. We'll go in here and have a look at our routes. You can see it's not happy with one of these routes because we've deleted our poor little NAT instance. It's actually saying that the status is a black hole. That's because that elastic network interface that was assigned to our NAT instance no longer is there. So I'm going to go ahead and remove that. Now I'm going to add another route. We're going to add 0.0.0.0/0, and the target, of course, is going to be our NAT gateway. So we'll click on that, go ahead and hit save, and there we go. So with our NAT gateway, the cool thing about NAT gateways is we didn't need to disable our source destination check. We don't need to put it behind a security group. If you go in and have a look at your NAT gateway here, you'll see, if we actually click on it, you'll see that it doesn't have any kind of a security group here. Amazon are going to handle it all automatically. Now, this does take a couple of minutes to actually prepare the NAT gateway. It's not as instant as your NAT instance. But the cool thing about NAT gateways is that you don't have to maintain them yourselves. Amazon maintain them all for you. So I'm just going to pause the video and wait for this NAT gateway to come back up. Okay, so this NAT gateway is now available. If I go back into my terminal window, so I'm back in my terminal window in my private subnet, and now if I just type in yum install MySQL -yes and hit enter, we can see that it is able to download and install it via the NAT gateway automatically. Okay, so just to summarize what we've just done, first of all, we created a NAT instance that sat behind a security group. We then updated our route table to route traffic from our main route table through that NAT instance out to the internet. And then we also, and this is really important to remember for for the exams, is we disabled our source destination check on our NAT instance. Now, the problem with this design is that the NAT instance is a single point of failure. If that EC2 instance goes down, or maybe we lost that availability zone, it's not, we're going to lose internet access to everything in our private subnet. You can do clever things like putting that NAT instance behind an auto-scaling group and using the NAT instance AMI in an auto-scaling group and setting the minimum number to 1, so that if you do lose that NAT instance, it will be provisioned, back in that public subnet. Then, of course, you'd probably want to have more than one public subnet and use multiple NAT instances across your public subnets. There's a couple of ways you can do it, but really people are starting to use NAT gateways now because you don't have to worry about managing the NAT instance yourself. So in scenario 2, we have our NAT gateway. That's not sitting behind a security group anymore. Obviously, our RDS instances are still behind their own RDS security group, but when we're communicating out to the internet, it goes directly to the NAT gateway and then out to the internet gateway. And so what you have to remember is once you've provisioned a NAT gateway, you always put it in the public subnet, first of all, and then you always update your route tables to point your instances to that NAT gateway. And then out to the internet. The great thing about NAT gateways is you don't need to apply security patches to them. And if you go into the Amazon documentation, if you go up to docs.aws.amazon.com/Amazon VPC, the latest basically user guide, and you just go down under networking, NAT, you can see a comparison of NAT instances and NAT gateways. So NAT gateways highly available. NAT gateways in each availability zone are implemented with redundancy, so you don't have to worry about auto-scaling groups or anything like that. But with a NAT instance, you're going to have to use a script to manage failover between your instances. NAT gateways support bursts of up to 10 gigabits per second, whereas NAT instances, it really depends on the bandwidth of the instance type. So when we were doing like our T2 micros, for example, that's probably not a really good idea in production if we're using a NAT instance, because they're going to fall over as soon as you get any kind of surge in traffic. That can be a common scenario in the exam, which is where your NAT instance is no longer being able to cope. What do? Well, basically you scale it up, you increase the instance size, or you change the instance family, and so that then you can support larger network volume coming out through your NAT instance. The great thing about NAT gateways is it's already automatically built in. The maintenance, obviously Amazon will always do the security patches for your NAT gateways. With a NAT instance, it's managed by you. Performance software is optimized for handling the NAT traffic on a NAT gateway, whereas a NAT instance is basically a generic Amazon Linux AMI that's configured to perform NAT. NAT gateways can be slightly more expensive. It really depends how you're using them. In some ways they can actually be cheaper. It really depends on your use, duration of usage, and the amount of data that you're sending through. If we scroll down and we just have a quick look at security groups, so you cannot associate a NAT gateway with a security group, whereas you can with a NAT instance. And then network ACLs, you can use network ACLs to control the traffic for both NAT gateways and NAT instances, because network ACLs operate at a subnet layer. And don't you worry, we're going to go into that in the next lecture. And then basically that's the main difference. So NAT gateways, people will always use them in production. Typically companies now will use them more than NAT instances just because they're a lot easier to use. You don't have to worry about single points of failure and then automating that failover if your NAT instance goes down. Okay, so you've done really well. Let's just have a look at our exam tips. So NAT instances have been around almost as long as EC2 itself. So they feature very heavily in the exam, even though they're not as relevant now since we've got NAT gateways. But you have to remember certain points going into any of the associate exams. The first and most important is when creating a NAT instance, remember to disable your source destination checks on the instance. Remember that NAT instances must be in a public subnet, and always remember, of course, that one subnet equals one availability zone. So if you're going to have redundancy, you're going to need multiple public subnets in multiple availability zones. There must be a route out of the private subnet to the NAT instance in order for this to work. So it's not enough just deploying a NAT instance into a public subnet. You've always got to add a route out to the internet. Another thing to remember is that when you deploy a NAT, it must have a public IP address as well in order for it to work. So you must allocate it a public IP address. And then the amount of traffic that NAT instances supports depends on the instance size. So if you're bottlenecking, the only way to stop that bottleneck is to increase the size of the NAT instance. And then finally, you can create high availability using auto-scaling groups, multiple subnets in different availability zones, and a script to automate failover from one NAT instance to another. It's really painful, but you can definitely do it. But Amazon listened to their customers. Customers always used to complain about this, and that's why NAT gateways were created. The last thing to remember is that NAT instances are always behind a security group. Now, NAT gateways are pretty much the way forward. They're very new, so they might not be in the exams just yet, but they're preferred by the enterprise. They scale automatically up to 10 gigabits per second. There's no need to patch them. You don't have to worry about running your yum updates on them all the time, and there's no need to associate with them with security groups. They're automatically assigned a public IP address, and just remember that once you have created your NAT gateway, you have to update your route table to point it to that NAT gateway, and then that will give you a route out to the internet. and there's no need to disable your source destination checks on a NAT gateway. Okay, so that's it, guys. You've come a really long way so far. The next lecture, what we're going to do is we're going to look at security groups versus network ACLs, and we're going to look at how we can block specific IP addresses, but also what the difference is between a security group and a network ACL. I've mentioned a couple of times, one is stateful, one is stateless. See if you can remember which one is which, but by all means, go and have a break now, and when you're ready, let's move on to VPC security.